Hello, my name is Lewis Flynn, and this chunklet will provide an introduction to how graph theory terms apply to aviation route planning. Here's the scenario. First Lieutenant I.B. Sandbag just arrived as the newest pilot to Marine Light Attack Helicopter Squadron 167. HMLA 167 is based in Marine Corps Air Station New River, which is part of the Camp Lejeune Range Complex. Sandbag is scheduled for his first flight in the area, and his instructor pilot tasked him to plan a flight route to visit all of the aircraft control points in the range complex, but cannot visit any control point more than once. Can Sandbag succeed, or is this just a cruel joke to play on the squadron boot? Here's an overview of the Camp Lejeune Range Complex with the aircraft control points. In blue shows the airfield, Marine Corps Air Station New River, and the purple represent the control points with their alpha designator. Between all the points, a white line is shown if there is an authorized route. For example, checkpoints Romeo and Hotel are close to each other, but there is not an authorized route. Flying from checkpoint Romeo to checkpoint Hotel would be an issue because between those 2 points is a tank gunnery range, and this is bad for helicopters. Take a moment and see if you can help Sandbag. Pause the video. A Hamiltonian path is a path that visits every vertex exactly once. Shown below is a Hamiltonian path using the Camp Lejeune Range Complex aircraft control points. Here's the map that shows the control points used with the routes between them, as well as the connections that we didn't use. Sandbag found a Hamiltonian path, but didn't remember the basic assumption that aircraft need to return to an airfield. Sandbag should have found a Hamiltonian circuit, which is a Hamiltonian path that is a cycle. Can Sandbag correct his silly mistake and find a Hamiltonian circuit? This problem, the Hamiltonian path problem, is NP-complete and is also known as the traveling salesman problem. The Camp Lejeune Range Complex aircraft control point graph does not have a Hamiltonian circuit, but removing checkpoint alpha from the graph does allow for a Hamiltonian circuit. The original graph on the left shows a Hamiltonian path, while the new graph on the right shows a Hamiltonian circuit. We can now see the Hamiltonian circuit that was enabled by the removal of checkpoint alpha from the Camp Lejeune Range Complex aircraft control point graph. These types of problems can be useful when considering primary and alternate routes, creating aircraft control points in a new area of responsibility, and flight route pattern mitigation to complicate an adversary's targeting plan. I hope you have enjoyed this chunk.